First things first, I'd like to welcome you all to today's Advantech webinar on LTE routers and gateways for industrial IoT. So once again, thank you all for coming. I'm going to be presenting this today along with Brenton Thompson, who is our technical manager here at the Australian office. Just to give you a little bit about myself, if you were in the presentation about HMIs a few weeks ago, you probably would have seen this before. I've been with the company since 2008 as a sales specialist, moved through as a product sales manager for a few years, did a bit of time in business development, and I've spent the last few years as the sales leader for the internal sales team. If you've got any questions during the course of this presentation, please feel free to put them through in the chat. I do have access to that up on my screen here, hopefully not what everyone else is necessarily seeing on the presentation. So if you do have any questions, by all means, feel free to ask as time goes on. Otherwise, by all means, drop me an email and we will have a look at the what the requests are and try to get the information to you as soon as possible. So moving through, what we're going to be covering today is we're going to be looking at the LTE routers and gateways, and there are two products that we're specifically going to be paying attention to today. Firstly, the ICR 3232s and also the BBSR 308s. We're going to be taking a look where they are positioned in terms of product placement, and we're also going to be taking a bit of time to go through the features and specs of both main models. We're also going to be taking a bit of time to go through some of the software, the firmware and the customization that is available to those units as well. We're also going to take a look at a bit of a deeper case study, specifically how a European company managed to achieve communications for a SCADA system for the national energy distribution grid. We're going to take a look at the global models that we've got access to, but that we don't sort of really touch on here. And we're going to spend a little bit of time in product selection, because as time goes on, as this presentation goes through, you're going to see that there are a lot of models, particularly in the BBSR 308s. So we've put something together to hopefully make it a little bit easier for you to select which products you're going to be potentially interested in as time goes on. So just to get started, this here is a bit of an infographic to highlight where our industrial cellular routers and gateways sit in the great big wide world. And one of the things I want to sort of probably take a little bit of time, just to sort of say up front, is that a gateway is basically a device that sits as part of a data acquisition or a network infrastructure. In these cases, particularly when we're talking about cellular, in a remote location, where you can then attach further devices or systems to them and then get that data into your private network. So as some examples of the industries that we can be looking at when it comes to industrial cellular routers, we could be talking about CCTV and security. We could be looking at transportation. We could be looking at energy. We could be looking at environment and management. As long as you start thinking beyond, let's say, the traditional factory, this is exactly where the cellular routers come into play. So traditionally, we'd go further out with, let's say, low data rate serial, Ethernet networks, fiber. When we talk about cellular coverage, effectively anything with cellular coverage can be integrated as part of your operations there. Just on the sides there, we've got a few graphics which we're going to talk about as things go on. We talk about some of the protocols that can be supported, namely MQTT, advanced routing, some of the legacy protocols there, such as IEC 104 and 101, Modbus, and most importantly, VPNs. Now, VPNs are something that we are going to go into in a little bit more depth. The thing that makes them really, really powerful, particularly on these cellular gateways, is that they allow you to take these gateways, wherever they are, and basically tunnel into your private network without all of the previous legacy problems that we had with things such as needing IP addresses from your carriers, without all those security vulnerabilities that go with them. Up top, We can see where the information can go. So we're talking about cloud platforms there. We've got management packages such as Web Access DMP, Web Access VPN, as well as sending information to your traditional SCADA servers and the like. On the side, we're going to talk, Brenton's going to go into this a little bit more about some of the software that can be used on these gateways, including Node-RED, Python, C++, and the fact that these actually run on a Linux operating system. When it comes to Node-RED, we are actually going to be doing a presentation on this at the exact same time next week. So if you're going to be looking at, or if you're interested in anything such as low coding software to help you do any sort of computational analysis or procedures at the edge, then I would strongly urge you, if you haven't already, to register for that presentation next week and yeah, so have a look at what we've got to present then. So the first thing that we're going to have a look at is we're going to have a look at the ICR 3232 and the BBSR 308 SmartFlex series. These are the two routers that we are going to be talking about today. So you can see the ICR 3232 on the left, and we can see the SmartFlex series on the middle to the right. As we go on, you're going to see that there's a lot of models for the SmartFlex series, but don't get too intimidated about it. We have broken that down and tried to make it a bit simpler. So when we look at the 3232, I would probably say that that's a bit more of our entry range right now. So when it comes to the specs on them, one thing to be aware of is that the 3232 and the BBSR308 SmartFlex gateways actually use the same software and predominantly most of the same hardware. So they're very, very common. When it comes to power, in terms of getting these things up and running, we're looking at wide voltage range on the DC side. So if you've got anything between 9 and 36 volts DC, these things will get up and running. So whether they run on 12 volt, 24 volt, whatever you've got, they will initiate. In terms of the connections, you've got 3 SMAs. You've got 2 there for GPS and cellular, as well as 1 reverse SMA for Wi-Fi, so that basically, dependent on the antennas that are being used, you can't really get it wrong. Internally, we're looking at 4 gig SLC memory, as well as 1.3 gig storage for your software applications. But being a Linux operating system, these things boot up very, very quickly, so you're not waiting for the system to take a long time to cycle up and get up and running. In terms of the temperature specs, you're looking at -40 through to 75. So wherever you need these things to go, they're probably going to outlast the people who are installing them. So that means they've got a lot of robustness in the field. You've got the built-in ports, such as your 2 Ethernet, your 1 RS232, your 485 port, as well as a digital I/O there as well. When it comes to the cellular connectivity, these are 4G units. So they also do have 3G and 2G fallback on the HSPA, GPRS, and Edge protocols. And what you've actually got here as a feature with the 3232s is you've got dual SIM. So that means if you are spread across 2 carriers and you lose coverage with one network, you've got another network to fall back onto. And that coverage there takes about 40 seconds. I'm getting a nod here. It takes about 40 seconds to transfer networks if one carrier goes down. Finally, especially with the wireless enabled unit, you've also got GPS capability there, so support for GLONASS, Baidu, Galileo, so that you know exactly where this device is, particularly if you're looking at restructuring more of a dynamic environment. It's got sleep mode as well, so that particularly if this is the type of thing that's employed for only getting information on a few times a day, if it's got very, very low sampling rate, this thing can go to sleep, particularly useful when you're looking at running on batteries or renewables. You've got the option there for Wi-Fi, and then you've got the advanced security features as part of the internal software. So when we get to the SmartFlex routers here, a lot of the features are going to be similar, but there's also a few more differences that set these apart. So got the same CPU internally, as well as the memory support for your edge applications. The voltage range for these is significantly wider. So you're looking at 10 to 60 volt DC on the input. And that there is going to be able to support that final point there when we start talking about power sourcing equipment and also powered devices. When it comes to cellular connectivity, once again, we've got the exact same coverage as the 3232, the same GPS support, the micro SD card holder, and you've got the same sleep functionality. With the SmartFlex units, we've also got a USB port and the option there to go for the Wi-Fi enabled units with the same advanced security features as well. So moving on with the SmartFlex, because the SmartFlexes have got a little bit more to probably look into there. You can see at the very top there, the part number for these is quite extensive. Now, we are going to cover this in a little bit more depth, particularly at the end of the presentation, to help you figure out which devices are going to be more suitable for you when you first start to look at these. But one of the features when it comes to the SmartFlex is being able to get PoE, PSE, power sourcing equipment models. So power over Ethernet power sourcing equipment means that these units can basically support the 802.3 AT and AF power over Ethernet protocols. So that means that these ports can give you 15.5 through to 25.5 watts per port. And the power over Ethernet is provided through both ports there, which are highlighted Ethernet 0 and Ethernet 1. So one of the things here, and I actually had this, I had to ask this question to Brenton the other day, what the difference between the power requirements are, is that the power supply to run the SmartFlex PSE gateways needs to be between 44 and 57 volts, and you're looking at a 60 watt power supply. Whereas the voltage range on the PoE line itself is between 42.5 to 57 volts. So that's going to be able to power most of your powered devices when they are attached to the PSE connections. So when we look at the power sourcing equipment, this is the type of example that we would be seeing. We can see that we've got our network on the left-hand side, all our firewalls set up, and then we have our gateway there with the power supply connected directly to the unit. Hanging off those Ethernet ports, we've got different example products and devices such as CCTV cameras, IP cameras. You could be looking at Wi-Fi access points, network attached storage, whatever it is that is power over Ethernet as a device. So one of the other models that we've also got is the SmartFlex PoE powered device. So this allows the router, this allows our gateway to be powered by a power over Ethernet port. So the power connector on the front of the SmartFlex router can be used as an optional, or can probably even be left disconnected, especially if you've got that faith in your PoE equipment. So the Ethernet cable that provides or accepts the power as a powered device is Ethernet 0. And the voltage range that you're going to be looking there is 42.5 through to 57 volts, which matches up precisely with the PSE unit. So you can actually have a PSE gateway powering a PD gateway. When it comes to the power supply here, you're going to be looking at 10 to 60 volts, but that there is an option as a backup only. So to give you a bit of a look at the powered device in terms of how that would set up, you've got the left-hand side there with the wide area network, which is exactly what we saw before, and we've got our gateway in the middle there. Now, being a powered device, you're going to have your external equipment being externally powered. So we can see that at the bottom, we've got our power sourcing equipment activating the unit. We've got our optional power supply, and then through the serial ports, the 232, the 485, the Ethernet, we've got other devices such as RTUs and PLCs as an example in this case. So To have a look at the product positioning, this slide isn't exactly all that dramatic. There's not exactly all that much there, but we can see the two products that we're specifically talking about there. We've got the ICR 3232, and then we've got the SmartFlex with a few more features, a little bit more price attached to it. We've also got the UR5i V2. Now, Brenton, can you just, for everyone, just explain a little bit about what the UR5i is?
Sure, Richard. So our UR5i V2 is our 3G device. So we've chosen not to put it in this slide because we're talking about 4G LTE gateways. And as some of you may know, 3G is on its last legs. It's being sunset, I believe, in 2021 to 2022. So we've put it in here just to let you know where it sits in our sort of positioning of things. If you do have a requirement for 3G devices, we can certainly help you, but we would recommend you use the ICR 3232 or the SmartFlex because it has the 3G fallback as well. Thanks, Richard.
Cool. Thanks, Brenton. So covering the product positioning, one of the most important things that we need to think about, particularly when it comes to cellular, are the supported bands. Now, the ICR 32 and the 3232W, which is the wireless version, support the I would say probably the common bands in Australia. So we've got B1, so we've got bands 1, 2, 3, 4, 5. We've got bands 7 and 8. Band 28 there is highlighted in green because that's the band that all of our carriers actually support. And then we've also got band 40 there. So with these units, basically straight out of the box, the internal comms module is going to be able to negotiate and interface with the cellular carriers that we've got in Australia. So when we look at the SmartFlex 308, so the bigger brother, just to go through a little bit more data here, yep, we know that the product range is wide, something that we're going to try to simplify a little bit later because there's 36 different models. They come in plastic and metal enclosures. The accessories do come with them. But most importantly, when it comes to the cellular coverage, all of the bands that are supported by the ICR 3232 are also supported by the SR 308. So we've got bands 1, 2, 3, 4, 5, 7, 8, 28, and also band 40 with the 3G and the 2G fallback. Most importantly, these products are RCM certified, so they are available to be not only sold but also activated in Australia. So now that I've gone through most of probably the simple stuff, I'm going to bring in Brenton to talk a little bit more about the software architecture and some of the deeper intricacies of these gateways.
Thanks, Richard. So as Richard's mentioned earlier, these gateways are based on Linux, which is an open source OS. So we are actually built off kernel 4.15 currently. And we also have our SDK for our software apps, which we call user modules. So we have a mix of proprietary and open source software. We have an extensive library of user modules, which allows us to add extra functionality to the OS, such as adding Python support, adding Node-RED support, that wouldn't be normally standard out of the box. And just as mentioned as well, we have a mix of GNU and proprietary software. Our GNU software is hosted on Bitbucket for peer review. All of our open source software is posted online, so you can go do your own analysis and make sure there's no nasties inside. And just on to the next slide. So in regards to our firmware features, this is a bit of a sterile slide. I'll just point out some of the main features, such as HTTP, TS, Telnet, SSH, and FTP. Now, when I talk about SSH and FTP, this is communication to the gateway. So you can SSH and FTP into the gateway itself. And one thing to point out, you have full root access to this device. So you have full access to the underlying OS. You can change, if you're Linux minded, you can change, update, add libraries at your own peril. Obviously, you can also brick the unit, which makes for an awkward email and phone call to us because we'll have to fix it up for you. But in terms of the networking protocols, pretty standard: DHCP, dynamic DNS, QoS, virtual router redundancy, VLANs, OSPF. VPN and tunneling, as Richard touched on earlier, we support IPsec, OpenVPN, which ties into our web access VPN, PPTP, Layer 2 tunneling protocol and GRE, firewall, URL blocking, diagnostics, and industrial protocol support, such as Modbus, both R2 and TCP, DF1, IEC 101, 104 for the energy markets. And being that this is our OS, that we can maintain full control of it, we can do quarterly updates for security and firmware features to keep your devices secured. So it's not just a router, but it's also an open development platform. Once we add in user modules to allow Node-RED and Python, both Python 2 and Python 3, as well as C++ scripting, so you can write your own applications for these devices. So you're not locked in to just what we offer on the gateway. Your imagination is free to run wild here if you can run Python scripts, programs, and Node-RED flows. We take it one step further by turning it into an industrial IoT gateway by using Node-RED and also Python, so we can send your data northbound up to Microsoft Azure, Amazon Web Services, ThingWorx, Splunk, Ignition, and Cumulocity IoT. These are already applications that we've got existing customers for worldwide using. And as Richard also touched on earlier, we support industrial protocols. We can convert Modbus TCP and RTU, IEC 101, 104, and DNP3 using our user module library. And just to touch briefly on our software platform support, we have Web Access DMP for management and provisioning of all our gateways. So you can send group updates for firmwares and configuration to a number of devices. Web Access VPN for our managed VPN solution. This is currently hosted in Amazon Web Services. This lets you have all your devices connect back to a central point and help it join your network effectively, as Richard mentioned earlier, without needing public IP addresses or public APNs and that sort of thing. And RCNet is a legacy software we have for network monitoring via SNMP, which is used by a lottery group in Poland. So they are monitoring 1,800 devices via SNMP with RCNet, which runs out of a browser. And we'll go over to our case study, which I'll flick it back to Richard.
Cool. Thanks, Brenton. So I think one of the things that we all probably want to have a little bit more information on is probably a little bit more context. Cold data such as all of the specs and features, that's one thing, but one of the things that we want to do, considering especially that we've got the means to do so, is show you how and where these have been used. So this is a case study that was published by one of our European partners about using these gateways for SCADA system and integration into a SCADA system of a national energy distribution company. So the objective that this organization had basically set down was that they needed to replace the entire existing comms network at 1,000 sites and then also install up to 4,000 new sites as part of their infrastructure, all making use of public cellular networks. So the challenges that they needed to overcome, the first one was being able to use legacy protocols such as IEC 101, the different types of sites, the different needs and requirements of each location, but also integrate them onto the same network. The prioritization of sites when it came to installation and making sure that the downtime was as short as possible. There was the security, the redundancy, and also the scale of the rollout itself. So going through it, when it came to the legacy protocols, as Brenton mentioned just a moment ago, when it came to the software, is that these SmartFlex gateways were actually able to do the protocol conversion. So when it came to IEC 101, 104, the software managed to handle the bidirectional conversion in the router itself between devices and also the main location for the SCADA integration. We also had the different types of sites, the different needs, all being tied into the same network. Now, particularly when it comes to the range of offerings here, it was solved by the various router models according to the site needs, because where the ICR 3232 is what we would sort of say a bit more entry grade, the SmartFlex routers have got a lot more options to be used at different sites as per individual needs. We also had the prioritization and short downtime, not only for the implementation, but also for failover. So the Smart Motion gateways there, not only did they have the dual SIM, so that they've got two independent cellular connections, but there was also an external satellite link available if both carriers went down. There's the high security, and exactly like I think what I've been trying to skirt around as a salesperson, when it comes to the access and the integration, that was solved through the use of encrypted IPsec tunnel on their VPN, utilizing their private APN that was given to them. We also have the redundancy here. So when it comes to solving this, there were two geographically independent checkpoints where they were terminated with the IPsec tunnels on the VPN before that information was fed back to the SCADA system. And then when it comes to the sites and the management, there was web access DMP. So that allows the organization to stand off from the units in order to be able to access them remotely, take care of the diagnostics, as well as being able to access them through the cloud and then be able to implement specific configurations on the gateways as required. So when we take all of those 6 challenges, this is basically what it looked like there. So we had the cellular networks in the middle. We had the Smart Start, Smart Motion, and SmartFlex routers in different locations throughout the network. We had the redundancy internally within the organization, followed by final rollout and visualization at the SCADA server itself. So when taking into account that case study there and the fact that that was in Europe, one of the things that ties in with that RCM certification that we were looking at slightly earlier was the ICR 3200 cellular router and gateway, the global map. Now, one of the things that you'll be able to see there is that, particularly in Australia and New Zealand, which the majority of us are all from, we here are looking at the ICR 3232. There are other units with slightly different model numbers, such as the 3231 for Asia, the 3231 for Europe, the Middle East and Africa, the 3241, the 3211B for North America, and then also in Latin America, we've got 3241, the 3232, and the 3231 as well. Now, I'm just looking at Brenton, and he's going to either give me the nod or he's going to correct me as I say this. In Australia here, we can supply you the 3232, particularly when it comes to not only developing your application, but also for national rollout. We can supply you with the other models, but you can't use them here.
That's correct, Richard.
So that means if you're an Australian organisation and you are developing for another region, you can use the 3232 effectively as the development platform, take that software and the customizations that you've done, drop that onto another region's model, and then basically pick that up and roll it out almost straight away. When we look at the SmartFlex global map here, this slide does have a little bit of legacy behind it, does have a few age issues, but we can see here that in Asia Pacific, it's the SR308 that Australia and New Zealand are interested in. I believe the 306 is for Korea.
309, sorry.
309 is for Korea, and the 306 is for the rest of Asia. We've also got those other region-specific models, such as the 303, the 305, throughout Europe and the Middle East, as well as North America. The same situation plays out. You can do the work here on the 308, and then that software can be dropped onto other models around the world, depending on what the applications are. So as we are starting to now get towards the end of this presentation, we want to look at the ordering information. So what is it that you're going to be looking at when you give us a call, when you drop us an email? The ICR 3232 is nice and easy. There's only 2 models. There's the 3232, and then there is the W variant. As you can see off that table there, and we made sure that the graphics were nice and big, is that the W has got the GPS support and also Wi-Fi. The 3232 has got the cellular, but it doesn't have those other 2 features. Most importantly, out of the box, the 3232s will come with your DIN rail clips, your wall mounting, they will come with your power and your serial connectors. But there are accessories such as your antennas and the power supplies, which we need to take into consideration when providing you with a hardware solution here. When it comes to the BB SR308s, I'm going to move through this relatively quickly because I don't think anyone is going to realistically look at any of that right now and think, yes, that's the model for me. In fact, with 36 models, it actually crosses 2 pages. So we're going to get onto the very last slide here, where we've tried to make it a little bit easier for you. For the BB SR308s, that is actually what the full part numbers look like there. So after the 308, there are 4 digits that are important when it comes to either trying to figure out what you need first or the things that we're going to look at in order to support you. So the first one there, the first digit after the 308 is, which we've highlighted in red as A, represents the Wi-Fi status. So if that 308 is following on is a 0 or a 1, it's all down to whether it's got Wi-Fi or not. The digit after it is relating to the PoE status. So if that's a 0, there's no PoE. If it's an 8, it becomes a power sourcing equipment, as what was explained earlier, where it can supply power to powered devices. And then if it's a 9, it can be a powered device where it can be powered via PoE. The third digit there is, I think probably the best way to say it is the version. If it's a 0, it's regarded as basic. I would probably say that when it comes to the 308s, basic should be in inverted talkie marks. If you see a number 1, that becomes a 3-port switch. If it's a if it represents 3, then it's got serial. And if it has 4, then your Ethernet and serial ports are isolated as well. And finally, we have X. And X there is either going to be a 1 or a 2, representing either a plastic or a metallic casing. So we would usually always recommend for industry to try to go with metal. However, if the application suits for plastic, then plastic versions are available. So for everyone involved, I would like to say thank you very much for attending the presentation.